Welcome. This video will show you the use of the Dektak 3030, CNM2's primary stylus profilometer. This video will be a great way to start learning about the tool. It'll also be a good way to catch back up on the tool if you've gotten rusty, but it won't be enough to train you on the tool on your own. When you want to use the Dektak 3030, come talk to lab staff and get some real hands-on training. In the meantime, let's take a look. So first off, what can this tool do? It's a stylus profilometer. What that means is it can tell the height of various things. It can tell the height of films that you've created, if you've deposited something, and it can tell the depth of etches that you've done. But it needs that step in order to tell the height. The smallest steps that it can tell are about 2 nanometers. The largest are about 120 microns. So that entire range will be good. At the 2 nanometer level, it's a little bit tricky though, so make sure to talk to lab staff before you try that out. If you need to see smaller films, then you'll want to be using an AFM. And if you want to be looking at larger etches or films, you'll want to be using a dial indicator. All right. You can also look at the breadth of various things that you've deposited. And in that case, 50 microns is the smallest breadth it can see, but it has a resolution of about 1 micron, which is fairly good for this kind of tool. Other options for telling the depth of something include CNM2's reflectometer, the nanospec, and CNM2's FEI Nano SEM. Okay, let's get started taking a look at the tool. First thing you have to do is activate the tool in Badger. After that, we'll need to turn it on. There's 3 different dials that we'll need to do for this. And unfortunately, all 3 dials need to be set correctly before we'll get a good picture. The first dial we'll want to turn is this bottom right one. This one here controls the light. Just turn it all the way counterclockwise. You can see the light has turned on the inside, and then just dim it back down. So it's a nice dim light on the inside. Next up, we'll turn on the monitor. Rotate this one by pushing it to the left, and there we go. Last up is typically we'll lower the needle to a height of about 1 centimeter. Right now it's already at this height. Otherwise, we can change this in order to get it there. It's not crucial that it's at proper height just yet. We'll be looking at this again in just a moment. We can see up here on the screen is the last person's run. We'll be making our own shortly. Today, we'll be measuring the height of this, which is a sample that I found lying around the DRIE. So it's probably going to be a 10 or 20 nanometer deep sample. Let's figure out as we go. To load your sample in, you put it down on this chuck here and then slide it slowly back. It's very important that you don't hit the needle on the inside of the tool. If you do, it's pretty harmful for it. Now when we've slid this in, you can see that the image on the screen has turned entirely white. What that means is there's too much light coming in from down here. So we'll just dim it a little bit. Aha! There we go. And the picture has come up. Another thing you can see is if the whole screen is too dim, that means that you'll need to turn this a little bit more. In any case, now we have a picture. We will need to be measuring a step, and this here is going to be one of those, but you can see it's really fuzzy right now. It'll be important for us to get this more in focus. How we're going to do that is to first press function 5. Kind of a strange one, hard to remember, but function 5 is the way to bring up these crosshairs. After that, push the up-down arrow. Push it just once, and that's important. If you push it, you see nothing looks like it's happening. If you push it again and again and again, it confuses the tool, and it needs to be rebooted before it'll come back online. There we go. Instead, push it just once. We'll see that needle has dropped down. If you're to look on the inside, you can see that the needle is actually touching our wafer now. And when we look at this, we can see that the needle and its shadow are touching each other. That means the needle is touching the surface. We're going to raise the crosshairs until it matches this level here. And what that means is we now know where it's going to be scanned later on. Once we've done the leveling, push the up-down arrow again, and away it goes. Okay, so next up, we need to find somewhere to measure. When we lower down the needle and we actually scan, the scan is going to start from the center of the crosshair and it's going to move to the right. Typically for a 1 millimeter scan, which is the most common scan we'll do, your scan will start from the center and go to the end of this white line here. So what that means is we need to get a trench that'll go through this white line so that the tool can tell how tall the trench is. So let's go hunting. You can rotate the stage around simply by grabbing it and spinning it like this. And that's a good way to get things vertical. There we go. You can also move it up, down, left, right, using these two wheels right here. There we go. Okay, so this looks like a good setup. Next up will be, we have everything set up for the scan. Now we need to tell the tool how to do the scan. We'll do that by pressing the program button right here. There's a lot of different choices for the program, but it pretty much all goes between a trade-off between the speed of the scan, its range, and its accuracy. In this case, we're going to start by having something with a large range, because we don't know how deep it's going to be yet, and very fast, because we don't want to wait that long. Later on, we'll set up a scan for accuracy. There's a bunch of stuff on the screen, but only a few of these we'll actually be using. The first one's the scan length. We'll set it to 2 millimeters. If you don't type in anything, it'll just assume you want millimeters. Later on, when we want it to be finer, this button right here will make it microns. The one above it does millimeters. It doesn't want 500 millimeters, so it's not letting me do that. Next up is the speed. We'll choose high. That will give us very poor resolution, but it'll go nice and quick. The profile, that's kind of a complicated one. The profile chooses where the graph starts. If you choose the profile of the dip, this one here on the left, then 0 height, your starting height, is near the top of the graph. If you choose the bump, which is on the far right, then 0 height is on the bottom of the graph. So if there's a bump, you can see the bump. And this one here in the middle, 0 starts in the middle. Let's start with that. It's an easy way to go. Finally is the measurement range. We're going to choose the largest one, again, because we don't know the height of this yet. The largest is 131 microns, and practically speaking, 120 is about the tallest we can get. The last thing on here is the stylus force. We'll talk about that a little bit more in a minute. For now, all this is set up. We can function 5 just to double check we're all lined up, and press the scan button. Before we push the up-down arrow button to lower the needle into the surface, when you press the scan button, though, it's going to automatically lower the needle and automatically do the scan. And so away it goes. Okay, it's a good thing we chose the middle one. I thought this was going to be a bump, and instead it was a dip. So this gives us a very general idea of how deep it is. This will look much, much better when we slow it down, though. There's going to be a couple things we're looking for. One of the more important is how well leveled is it. Right now, this looks pretty well leveled. I'm going to screw it up so that we can actually see what it looks like when it's not well leveled. And that should do the job. When it's not well leveled, we're going to get a slope in the line as it goes. And what's happening there is quite literally, the tool is seeing the change in height from your wafer not being completely flat. There's two ways to get rid of it. We're going to see both of them. The first and the more, there we go. So the first and the more difficult way to get rid of it, but the one that always works, is by actually doing it mechanically. What we're going to do is use this big circular wheel on the bottom. This will help us level the wafer. The big circular wheel kind of sticks out a little bit on the right, and that's where you want to actually be touching it. If you push it, it will lower the slope. If you pull it, it will raise the slope. So we see now that the slope is too high. So we're going to push it a little bit and scan again. And we're going to keep going back and forth, checking the slope and either pushing or pulling on this part of the dial until it gets nice and leveled out. It doesn't need to be perfect at this point. It just needs to be close enough. The last little bit we can take care of by using the software on the tool. Hey, it looks pretty good. Normally it takes a few guesses. The slope is a little low now, so I'm just going to pull a little bit on this, and we'll call it close enough. Okay, next step. Let's slow down the scan. Let's tighten up those ranges so that we can get a better look at this dip. First thing we're going to do is decrease the scan length. 2 millimeters, as we saw, was really long. It went way off the side of the screen. So we don't need that much. We want 500 microns. We'll type in 500 and this button right here for microns. I got 50 microns. Hang on. 500. Oh, geez, I'm having a hard time. There we go. Next up is the speed. We were doing high. Now we'll be choosing low. That'll give us much finer resolution. Actually, let's choose medium. Low's a little bit too low for a video. Profile, we now know that we want the dip downwards, and we saw that it was about 20 microns from our fast scan. It would be nice to choose the smallest range, which is 7 microns, but it's too small for us. We'll choose the medium one. Okay, and away we go. One really common question on this tool is we're taking a needle and we're dragging it across our sample. Isn't that going to scratch our sample? Surprisingly, no. I've tried and I've tried and I've tried to scratch a sample with this thing, but it repeatedly refuses to do so. Photoresist is just fine. Metals are fine. Soft-ish glasses and things like that, it's all fine. The only thing I've ever gotten to scratch in this tool was a film of indium, which is a material that is 20 times softer than gold. Okay, it looks like we're a little bit off to the side. That's okay, this will still be just fine for our measurement. You can see there's a little bit of slope left in it. We want to get rid of that. We're going to do that using the level button. So this is going to be how to level things using the software. There's 2 cursors on here, one labeled R and the other labeled M. The R cursor is called the reference cursor, and you can move it around by pressing ref and then pushing a button. You can see now we have control over it. If you want to move it quickly, you can hold the fast button and move it quickly, so it's just the arrows. What we're going to do is put the reference and the measure cursors far away from each other, but on 2 points that we know are level. Like so, and then we'll press the level button, and the tool will automatically level them out. Now we have everything leveled out. We can see very cleanly the top of our wafer and the bottom of our etched hole. Now what we want to learn is the important thing: how deep is this pit? We leave the reference cursor on the top, we'll move the measure cursor to the bottom, and the height will be listed right up here on the top right. 22,000 nanometers, so 22 microns. Okay? This tends to be accurate within a couple of percent, and we double check it by the other measurement tools we have in the lab. So our other reflectometer, our other profilometer, and our SEM, and they all stay in pretty tight agreement with each other. So the measurements on this are pretty darn reliable. All right, let's take a look at how to make this graph a little bit prettier. You can see that the thing we're trying to measure is way off here on the side of the screen. Let's say we want to have a nicer, prettier graph. What we can do is zoom into this part of the graph. You press the left button, and this will select the left edge of our graph, and you can move it just like we were moving the cursors. There we go. Now you hit the replot button on the bottom right, and it'll redo the plot. Now it looks a little bit nicer. When you're done, when you have a picture that you like, you can hit the print button, and it'll print on the printer up top. Is it going? It is. In just a minute, I'll show that off. But you can take this back, stick it into your lab notebooks and things like that. Great. All right, so we have talked about how to do the etch depth. Next up, we haven't yet talked about how to measure roughness. So this tool is really good for measuring etch depths, the height of films and things like that. The 2 other things it's useful for is measuring the curvature of a wafer. As long as your wafer is less than 20 centimeters, so if you got like an 8-inch wafer or less, you can measure how much bowing is on it by setting the scan length to be very, very high. The other thing you can do is measure roughnesses. We'll do that by lowering the scan length a little bit further. Let's go down to around 300 microns. We're going to lower the measurement range all the way and lower the speed down to the low setting. The stylus force, I tend to like setting to 10 for this, but honestly speaking, it doesn't matter that much. Now that we have this all set up, we'll hit the scan button, and what we'll see here is how rough our surface has become. The top surface of this is oxide that has silicon oxide that's been etched in the DRIE, so it's liable to have just a little bit of surface roughness. And we'll see just how slow it goes when we set it to the slow mode. We'll also talk about how to interpret the data that we have on here. Let's see here. And some of the common artifacts. Something I should have pointed out before when we actually had the picture on the screen. One of the most common artifacts is, even if you have a completely vertical wall, it winds up looking like it has kind of a rounded edge on it. The reason for that is, as the stylus drags along, when it reaches the wall, it tries to hop up over the wall and it winds up deflecting a little bit when it reaches near the top. And that deflection shows up as a little bit of a, oh, perfect, a little bit of a kind of cut in on either side of it. We'll take one more look at that, but in the meantime, that's ideal. We'll stick the reference and the measure cursors, two places that look like they're relatively flat, so just get them off of any points. Hit the level button. There we go. So we can use this to estimate the RMS roughness. This is very useful for the bottom of etches. It's also kind of useful for the top sometimes. And we can see that the RMS roughness on this is going to be, the roughness is down beneath a nanometer size scale, so pretty darn low. This is nice and smooth still. Cool. Let's take a look at some of those artifacts. We're going to redo the program back to how it was before. Set the scan length to maybe micron, the speed to medium, profile in the middle. Set that to a little bit higher. I think this needs to be 1.5. Except I don't know how to do that, so we'll just do 2 and go. All right, so the common artifacts, the first one was that. Another common artifact you'll see on this is, on very rare occasion, the level of the height will simply jump. And it tends to be fairly obvious when it does this. It's not happening in real life if you see the height start at 0, then instantly go to 2, and then you see the rest of your sample. There we go. This here is the artifact we were talking about. You can see as the needle goes over the edge, you get a little bit of deflection there. As it comes over the top, you get a lot of deflection. So these aren't there in real life. In real life, this has nice flat sidewalls. And last up is if you have the measurement range set too low. Then what we're going to see is when the tool goes outside of its measurement range, it'll suddenly just start returning 0 as the height. And it'll be good to be able to recognize that so that it does not get you. Here we go. All right. So we can see that the line still exists down here, but this isn't actually the depth of our pit. It's just saying that it's down here at 0. The other thing is if it goes off the top of the screen, it'll also hop down to this 0 level. So it looks like we have this little perfectly flat thing there. If we hit the level button, it's going to replot it. We have this weird shape. Doesn't exist in real life, so watch out for that. Final thing to watch out for is the vid button. It's very easy to hit this by accident, and when you do, your sample disappears. The vid button is the meanest thing. I don't know why the designers put it in there. But if you press it, it'll cycle through 3 different states. One state, the one that we want to leave it on, shows us both the screen and our sample behind it. The next state shows us just the screen, and the final state shows us just our sample. Incidentally, if you come to the tool and you're not able to see the screen or you're not able to see your sample, sometimes the vid button is the one giving the trouble. Last thing we can change in the program screen is the stylus force. The stylus force is how hard the needle presses against your surface. And honestly, any choice between around 2 millinewtons and 20 works just fine. For the most part, for just measuring film thicknesses and things like that, they work exactly the same. And 20 is not going to scratch any normal materials. If you are trying to measure the roughness of something, I prefer 10 millinewtons because it gives good, consistent results. Last thing we're going to do is take our sample out of the tool. It's kind of polite to hit function 5, just bring up the crosshair before we leave. We'll open this back up. This, by the way, helps when you're measuring roughnesses to keep this closed. We'll slide our sample out. Turn off the lamp on the inside. We'll do that by turning this all the way counterclockwise. Turn off the monitor. And we're done. Okay, thank you very much for watching this training video. Again, if you have any questions, please come and ask the lab staff. We're more than happy to help on this. And when you want to learn how to use the tool, if you need to use it as part of your process, come talk to us. We'll give you the training. Look forward to seeing you.